Hi guys, and welcome to another video in the Energy System Analysis Python course. My name is Anas Abuzayed, and in today's video we will talk about Pandas. So Pandas is this tool built in Python. It's a library, of course. It is used for data manipulation and data handling and dealing with data. Think of it simply as the Microsoft Excel of Python. So to start directly with it, we know previously how to import libraries. So import pandas. Normally what you will find is import pandas as PD. So that's how we import it. So in pandas, there is two types of data structures that you need to worry about. One is called a series and the other one is called a data frame. So think of series as a one column, a one dimension data structure where you can have one column and different entries, different rows. Where data frame can be either one or multiple columns, also with different indexes or different rows. So let's start with the easiest one of them, the series. So how to define it is by using pd.series. So it's basically an empty series here. Let's say A equals the series, and let's just put data in there. So let's say 200, 400, 600, and 800. So in this one here, I would just say the index. So you define the data, the inputs that you put in the column, and your indexes. So let's say the identification of each of the indexes. Of course, you can do it without it. So you will have a series that starts from 0 to whichever number you finished on, or you can have an index, again, another list. Let's just put random carriers, random technologies. So solar, on wind, off wind, and run of river. So if you run it now, you have one series, right, of, so a series A of different indexes and different values. So that's one way of defining it, by using it directly with a list for the index and the list for the values. Another way to do it by using dictionary. So we learned previously how to create a dictionary by having the keys and the values. So let's do another one. Let's say, so how to create a series out of it by just simply saying, let's say also B, we use the same one, pd.series, and then just B. So B now, instead of a dictionary, it's a series with different indexes and different values. So in order to create a data frame, you can either use one column or multiple columns. Mostly in this course, we will deal with a lot of data frames, not a lot of series, I would say. So for the series, we will not go much deeper in there. So let's now create a data frame. So df equals pd dot data frame. And in here, if you see it now, it's an empty one, of course. So in the data frame, you can create it using, let's say, different combinations or different ways to create it that we will show you now how to create a data frame. So one of them is, of course, by using a dictionary. So let's say we use data set 1, and this is A. So this is our series that we created before, which is this one. And let's say another one, data set 2 is B. So now our data frame, if you remember from A, it has solar, on wind, off wind, and run of river. So you find those off wind, on wind, run of river, and solar, where data frame 2 or B has coal, on wind, oil, and battery, which is here, coal, oil, battery, and on wind, this one. So here, because we had different series where not all the indexes exist in both series, so it simply replaced them by none, so not a number. Because it has no value, it has no entry in there, so it replaced it by using not a number. So let's say we want to add another column to it. So let's say we want to add dataset 3. So how to do it is simply by using like this. So dataset 3, without using any indexes, without using the names, the solar, the say the indexes, the different technologies, just by putting a list. So how many entries do we have in here in this data frame? It's 1, 2, 3, 4, 5, 6, and 7. So we need to have 7 different values that will come on top of it. So another column and will be added next to it. So let's say for coal, we use 1500 and then 600 for oil, let's say 40 for battery and 1500 for off wind, let's say 900 for on wind and 1200 and then finally 300. So now if you check DF or let's say our data frame, it will be added respectively or in order, in this order that you put here. So this is the 1500 and the last one will be the 300. Let's try to do it instead of having 7 entries here. Let's say that we enter just 5, or let's say 4. Now, if we try to do it, let's say dataset 4, that we want to add a new dataset where it only has entries for the first 4. So the coal, the oil, the battery, and the off wind. And if we try it here, this will give us an error. Why? Because adding a dataset using this way would give you an error because it needs to know what exactly the order. So the length of the value 4, in this case, does not match the length of the index of the data frame, which is 7. So either we do it this way if we want to do or to add a column with a list, or there's other ways that we will show now. So adding it like this and simply saying, okay, Python or Pandas will put the others as NaN or not a number will not work in this case. Another way of doing it, or let's say of adding a new column to this data frame, is by again defining a dictionary. So let's say D is our dictionary, and then we put all the values. So now we have this new dictionary that we call D, and then we can simply add it on top of it. So either by saying df, and then we call the new column dataset 4 equals D. Now we have it. So we have this one. Or we can say df, let's say dataset 5 equals pd.series. And then we created previously a series from dictionary. So we can add a new column by adding a new series next to it. Just in case that we don't want the same numbers, let's just multiply it by 2. So PD series of this dictionary times 2. So this is our new dataset 5 or our new column. Now we have 5 columns, different powers or different nominal powers, nameplate powers for different carriers from different datasets that we randomly created. So what's the difference between adding it from a dictionary where we identified all of them and when we added it from a list? So let's check what would the difference be. It's in 2 things. One, you don't need to have the same order. So let's say in our data frame, solar was the last index. Let's just say, let's copy paste this one. So let's say E, a new data frame, and let's just put solar in the beginning and put coal in the end. So this is our new dictionary. And then let's just manipulate the numbers a bit, just to have a bit of contrast, just something like this. So if we copy the same now, we have 4 and 5. So let's say dataset 6 equals E. And then we open it now. We will see that even though the order is not the same, so previously when we added it as a list, we had to follow the order. So if you check dataset 3, the first one is 1500, then 600, 40, 1500, 900, 1200, and then 300. While when we add it as a dictionary with the keys, it basically identifies the keys as the index and then add them accordingly. So solar, even though it was the first one, so it should be here if we added it as we did previously as a list, but it was correctly added. So solar is 450 and coal, even though it was the first one in the data set, the last one in the dictionary, it was added correctly. That's the first difference when we add it as a dictionary. The second one, let's again copy paste it, is we saw previously when we did a list, we had to do the exact same number. Otherwise, we get an error that the index does not match the length of the values. So let's say if we have 4 or 5, while in dictionary, let's say we remove battery and we remove coal. Let's say this is F. So now we have this one of 5 values, and then let's say data set 7 equals F. What will happen is that it will add values where it's there, and in case it's not there, it will put not a number instead. So here, one thing to note, or let's say to learn, is how to drop either columns or rows. So if we say df dot drop, we need to put the name of what exactly you are dropping. So let's just drop dataset 1 and then execute it. So it says that it is not found in Access. Why? Because we always say that the Access 0 goes with rows. So with, in this case, with the carriers, Access 1 goes with the columns. And we said previously that Access, in case it was not defined by you, by the user, it's always the default is 0. So if we say Access 1 and execute it again, now we see that dataset 1 is dropped. So what's the difference? Here you see it, because we did not say df equals, so we did not assign it, we just executed it. Then we see that it was not dropped. So dataset 1 was not dropped. How to do it is by using something called in place. So in place is equivalent to doing this. df equals, so either you do it with in place, which basically says the result of this command, put it inside df and make it the new value of it, which is the same as this one here. So if you run this one and then print out df again, you will see that dataset 1 now is dropped. And if you want to, let's say, drop one of the rows from here, so it will be the same. Again, you put the correct name, so the name of the carrier. I will not put it here, or I will not execute it, and then either access 0 or just don't mention it because, or don't write it because it's the default value inside Python. So if you say, let's say, off wind, let's just do it without the in place so that it does not take place. So we have to drop off wind. Here you see that off wind was gone. So now we have our data frame. Let's see how we can access the indexes and the columns. So df.index will give you all of the indexes. So you can make a for loop over them, something like this. Or let's say for tech in df.index, print tech. So you access them each time. Or df.columns will give you your columns. And again, you can also iterate over them with a for loop. So let's say that we found a new data set, or let's say new technologies from this data set. So this basically is a new data frame that we have 2 columns, data set 1 and 2, but our indexes are not the same as we had before. So here we had coal, oil, battery, off wind, on wind, run of river, and solar. Now we have a new, let's say, or new values, but only for data set 1 and data set 2. So if you check df, our previous data frame, we had data set 2, 3, 4, 5, 6, and 7. While here we have only data set 1 and 2. So 1 is already dropped, and we have different indexes. So let's execute this one. And now we want to merge both. So how can I do that? Is by concat. So here we need to put the two data frames that we know need to merge or to combine. So df, the old one, and df new, the new one. And I need to put the axis. So do I need to add them as new columns or do I need to add them as new rows? So we need to add those carriers which do not exist in our index or in our previous index as new rows. So either I just say axis is 0 or we know that the default is 0. So now if we run it, you'll see that data set 1 is now back again, but only with those new values. So CCGT, OCGT, hydrogen, and nuclear, while everything else is just NaN. And for the new carriers that we added, so CCGT, OCGT, hydrogen, and nuclear, we only see values in dataset 2 and dataset 1. Everything else here is just not a number. Now, where is this result saved at or assigned to? Nothing. So we need to add, or let's say define something, a variable, let's say X or Y, that we say, okay, the value should be stored there. So I'll just say results. Now I have a new data frame, which is the result of the combination of the two previous data frames. Let's say we had a new data set where we had new data sets, found new data sets online that we want to call them dataset 8 and dataset 9. So again, for time, I'll just copy paste it. So it's dataset 8 and dataset 9 with 11 values, which are those 11 values. And I just want to add them next to each other. So as columns, not as rows. Let's just define this one. Now we have it here, which is a new data frame with two columns, the same technologies. And here I said index equals the previous index. So this same index that we had before. Now let's try to concat them, to merge them together. Let's say instead of result, let's say just data. So we have no variable called data. So I want to merge result and df new 1. Now I want to add them as columns next to each other. So here we need to identify the axis, because if we add it as 0, it will be added as an index. But I want to add it as a column. So let's try it without assigning it. Now let's see what happens if I say axis 0 or if I just remove it. Basically, it will have duplicate of axis. So you see call here where it's only all data sets or only the data frame has values. So I will have a double indexes here. So call is here, call is here, all is here, all is here. So that's not what I want. I want it with axis 1. So as we expected, we want to add it as a new column. So now we have our data, which is 9 data sets, different carriers, different values. Now we want to learn how to access data frames. And there's something called conditional selection. I think if you master this conditional selection, how to select exactly your data, you will be very good in Pandas and generally in data manipulation, data analysis, and so on. So let's say I want to have only this one, so only data set 2. How can I access it? By saying data set 2. Since there is no space, I can just say data.dataset2. So if there was a space, for example, like this, and I run it, I will have an error. So in this case, I can access it like this. If you saw here, dataset 8 has a space. So if I want to access dataset 8, I can only access it using this way. So if I want to write 8 here, it's okay that it has a space. But if this one was not true, so if you want to access it using the second way, by using dot, then you will have an issue. So we'll have an error here. So what we want to do is to rename it. So we want to rename this data set 8. So we want to rename this new column. By doing so, we can access it using other ways. So I just wanted to show you how to rename a new column or how to rename a column. So how to do it is by saying data.rename, and then you open a dictionary. This is the old one, so data set 8, and you want to say data set 8, so without the space. Now you need to identify the axis. So it's not 0 because it's not in the indexes. So if you remember, it's in the columns. So axis is 1 and execute it. So now it's perfect. Let's try this one again. Dataset 8 and run it. It gave us an error. Why? Because as we said, if we don't put in place or data equals this new command, it will be executed, but it will not be stored. So now if we try it again, now it's stored. Let's check data. Dataset 8 is there. So if you do it like this again, now you will find it that it's working. So let's go back to the data. Here we have two things. How to access exactly this. So let's say that we want to access this 1600. So this one here, which the column is dataset for, and the index is Offenburg. So how can I exactly access it? By using something called loc. So location. The first entry in location is the index. So here it's the index, here's the column. So index name and column name. So let's try it. What's the index name? It's Offenburg as a string, of course, and dataset for. So we have this 1600. Let's say we want this 1500. So it's dataset 8 and OCGT. So index here, our index is called OCGT and it's dataset 8. So we access it. Let's say I want all of the on-went values. So let's say this one. So we do the same. Here it's on-went, but I don't want only dataset 8. I want all of them. So either by doing something like this, which will give us all of those, or like this. So it's both are the same. So you can access, let's say, all of the data sets, all of the columns, but only at one index. Same thing would be if you want to do, let's say, data set 2. But here we already know that we can do it like this one, without using loc. So something like this. Another way of doing it, let's print out data again, is by using something called iloc, so the index of the loc. So here we have the name of the index. So coal, oil, battery, solar, whatever. But these also have indexes. So this index is 0. This is 1, 2, 3, and so on. And this is 10 because it's 11 rows. So the last one is the 11th row. The index is 10. So data.iloc. Basically, it's a number of index, let's say, or index number, and column number. So same thing also goes for the column. So this is 0, 1, 2, and so on. So how can I access it? Let's say I want to access this 1200. So this is index 0, 1, 2, 3, 4, 5. This is 5. And it's the second one. So this is the 1800. It's not the second, it's the first. But it's the second, but in Python, it's the first. So that's it. Same thing also happens. Let's say we want from battery to solar. So 0, 1, 2 until 0, 1, 2, 3, 4, 5, 6. Either I say till 6, but now I know that it will not include solar. So 0, 1, 2, 3, 4, 5, and 6. So this will not be included. Or I just say till 7, so solar will be included. And let's just say, okay, we want the second and the third. So 2 till 4. So it will have the second and the third. And so we can select with it by using loc or iloc. So now let's see the most important thing in selection. It's called conditional selection. Let's say that we want to show only coal, off-wind, on-wind, and solar. How can I do that? So either by using ilock or lock, or I can do something like this. So let's say we want so this is the first one. We say true. And then second, third, fourth, fifth. So the fourth and the fifth would be also true. Just to add another bracket here. So by doing this, I can access exactly which ones I want. So if I do it like this, we have coal, off wind, on wind, and solar. So this means if I say data and then I open a bracket, and in this bracket here, I have a list of conditions, then I can say, okay, I want to show this data or that data. That's called conditional selection. Let's say we want data, for example, let's print it out, where it's more than 200. So here you have an output where it's true and false. So if we put this one inside the bracket and then execute it, all the values more than 200. So if you check this one versus the original one. So for example, battery and off wind in data set 2. So battery has a value of 10, off wind has a value of NaN. That's the original one. Where when we put the conditional selection, battery, because it's not more than 200, it has a value of none. Off wind was already NaN. So by using that, we can have more of a selection. What do I exactly want? And what do I want to show? How do I select it? So let's take another example on this one. So let's say that we have, or we want to show this data, the whole data frame, only when data set is more than, let's say, 600. So how can I do that? Is by saying data set 2, that's our data set, and then more than 600, and then this one here would go in here. So now we see only when data set 2 is more than 600. So let's just show all of it. So where is it more than 600? It's with coal, with on-wind, and OCGT and hydrogen. So here we see coal, on-wind, OCGT, and hydrogen as a result. So let's say from the same one, from this one, we want it when data set is more than 600 and data set 9, let's say, less than 1000. How can I do that? Let's do it separately. So let's say we want when data set 9 is less than 900 or 1000, let's say 1000. So this is data set 9 where it's less than 1000. That's the original one. So we show the original one. Only OCGT will go out. Everything else will stay the same. So how can I combine both conditions here? Where I want to show the data only when this column, data set 2, is more than 600, and this column is less than 1000. So we see this condition here when we had it more than 600. And because of the new condition, we expect that only coal, on wind, and hydrogen will be there. OCGT will be gone. So how to combine both conditions is by doing this. So first here, then and then this condition. So now if we run it, we will see it the same. So let's say instead of and, either or. So either this is more than 600 or this is, so this is more than 1000. So here we see that in both cases, so here let's go one by one. So in this case, coal data set 2 is more than 600 for coal, less than 1000 for data set 9. That's true. For oil, the first condition is false, but the second condition is true. So it will be executed. So that's called conditional selection. That's mostly on the column side. So let's see if we want to do it on the row, on the rows. So if we show our original data frame, that's data, and let's say we want values where solar is more than 200. So data.look solar. We want to show values where where solar is more than 200. So that would be not 200, let's say 400, let's say 400. So in this case, this will be gone, this will be gone, this will be gone, and we'll end up with 5, 6, and 7, and 8. So how can I do this? We said we end up with data set 5, 6, 7, and 8. So if we do it like this, data set 5, you know how to do it. Now, if you want to do 2 columns, so we need to have a list of columns, data set 5, and then data set 6, data set 7, and then data set 8. I think, yes, that's good. So now if we do it like this, that's my condition. Solar is more than 400. So in all cases, it's true. But this is not smart. This is done manually. So how can I do it? Let's try to do it step by step because it's a bit complicated. So first, I want to show where solar is more than 400. So now we see that we have data set 2 false, 3 and 4 false, as we expected 5, 6, and 7, and 8 are true. Now, we know that data.columns gives us all columns. What happens if I combine this one that will give me those conditions with data.columns is that we will end up with those columns. So 5, 6, 7, and 8. Now, if I put this one, so maybe just to do it step by step. So data.columns, and then this one next to it. And then finally, I say data when data.columns, when data.look solar is more than 400. So this is the first condition, that's more than 400. Then give me the columns with those conditions. So we know the columns are all of those. So it will give false, false, false. So this is gone, this is gone, this is gone. Then 3 trues. This is correct, true, true, and true. And this is false. So data set 1 is false. Then this is true. And lastly, it's false. So it will end up, or it will give us back those ones here. And then if we try it, or if we run it now, then we end up with columns where solar values are more than 4. So that's for the conditional selection. Now let's move to another topic. It's called the group by. Let's create a random list with nominal powers, voltages, and carriers. So I want to have a random list. Let's say carrier equals an empty list, voltage equals an empty list, and then we said pnom equals another empty list. So I want to add 20 entries, for example. So we learned previously from NumPy that we can create it. So I want to have a for loop, let's say for I in range 20, and then carrier equals append np dot random choice. So I'll give it a choice of either solar, on wind, and off wind. But before we execute that, we don't have NumPy imported here. So this one would give me a random choice each time between one of those carriers. So I would do the same for voltage, and then I would have a list of numbers. So let's say 60 kV, 120, 220, or 110, 80 for the extra high voltage and 525 for the HVDC. And then let me try it first. So, ah, so here it will give you always a random number out of those numbers. And then finally, P-num, any number below 10,000. So let's try it out. Now we have carriers, different carriers. Of course, when you run this code, you will have different results because it's totally random. Voltage, we have different voltages and different nominal powers. So now let's create a data frame out of all of those. So now we have our new data frame. So there is a very useful function in data frames or in pandas that is called group by. So if you group or if you want to group your data based on, let's say, wherever it's off wind or wherever it's solar or wherever the voltage is 110. So that's why, or that's where you use group by. So you group by, let's say, by the name technology, so by the name of the column. If you run this one, that would give you a group by output. So here, if you want to see all of the outputs, say groups, then you will see it. It will return a dictionary with the groups based on the off wind, on wind, and solar. So these are the indexes. Let's say VF again. Just try to make this one smaller. So let's say for the off wind, it's at 0, 2, 3, 7, 8, 10, 14, 15, 16. So 0, 2, 3, 7, 8, and 10, 14, 15, and 16. Those are the carriers, or let's say the indexes where this technology can be grouped in one, so off wind. So let's see what we can do with it. So for example, we can know the summation. Of course, not the voltages, but of the nominal power. So in our case, it was 42.8 gigawatts of off wind with 16.7 on wind and 28.6 gigawatts of solar. If you want to do even the mean, so the average. So again, for the voltages, it makes no sense, but for the nominal power, that's the average power, let's say. I think for both, it makes no sense. But so you can have the maximum and the minimum. You can have something called ID min or ID max. So what does this mean? ID max, ID X max, or ID X min. So this basically says for off wind, the lowest voltage is the index 2. So if you go to DF, index 2 of off wind, this is the lowest voltage you get. And if you do it, for example, let's say for the nominal power, index 7, so this is the lowest power for off wind. That's based on this data. Of course, as I said previously, because it's completely random data, when you run it, you might have different results, but it's important to know how to read those results or how to interpret those results to understand them correctly. Let's do it on the voltage. So DF voltages. So here, because it's voltages, not voltage, so it gave us an error. So based on that, and then we say groups. So you will see that there is those groups, so 3 voltage or 3 power plants with the voltage 60 kV, 4 with 110, and so on. So let's see if we say mean. So the nominal power of the voltage 60 is 3,869. So if you want to sum them, and do the same exactly, the same functions you can also get from here. So here it says, okay, on the medium voltage, let's say roughly 41, on the high voltage, roughly 36, and on the DC side, it's 9,000 megawatts. So just random numbers just to show you how to group data and so on. So we can do the same instead of group by using conditional selection. So we said this is our data frame and we want, let's say, let's go back to the technologies and the summation of it. So we can actually slice this data frame by saying df dot technologies equals Offwind. So this one here would give me where the technologies or where each entry is Offwind. And then, as we said previously, if we do it in a bracket, return it to the DF or the data frame itself, then it would give us this. So now if we say, now this here is a data frame on its own. So if we say type, this one is already a data frame. So how can I select one column out of this data frame? Either by saying dot, the column name, or by using a bracket with it. Here, because there's a space, then we can only use it like this, or with dot loc or dot iloc. So this one, and then dot summation, this would give you 48. Now, if you go to this one here, so for the Offwind, it's exactly the same. Let's say we want for the voltages. So we said in the voltages, on the 60 kV, we have 11,608 megawatts. So the same thing. So df dot voltages equals 60, and that will give you where exactly it's 60. So it's at 5, 9, sorry, 5, 9, and 17. If you say df at 5, it's 60, at 9, it's 60, and at 17, it's 60. So if we do the same by saying df, this one, and then again, nominal power, and then dot sum, that gets 11,608, which is the same as this one. So it's either you can use it by group by if there is something in common between those. So in our case, it's either the technologies or the voltage levels. So you can group them based on that, or you can just get the ones that you are interested in. So for example, you're interested only in the Offwind, not in the other groups. So do it this way or that way. It's both the same results. Thank you for watching this video. I hope that you learned a lot with it, and we will see you in the next video.